Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
This episode was sponsored by the PVS Studio team. It promotes static code analysis methodology in general and its PVS Studio tools in particular. Static code analyzers allow you to find bugs in source code at the development stage. This helps to reduce the price of fixing them.
PVS Studio performs code analysis and issues warnings on the fragments of code with a high probability of having bugs and potential vulnerabilities in them. The tool supports C, C++, C#, and Java, and it can work with Visual C++, GCC, Clang compilers, and some of those used for embedded systems. The analyzer works on Windows, Linux, and Mac OS. PVS Studio can both be used as a standalone tool and integrated with Visual Studio, IntelliJ IDEA, SonarQube, and so forth.
In the show notes, you can find links to the PVS Studio website and the article Technologies Used in the PVS Studio Code Analyzer for Finding Bugs and Potential Vulnerabilities.
Happy Halloween! It's Halloween, I guess, in the countries that celebrate that when this episode comes out. So we just wanted to say happy Halloween to everybody. Lots of projects have a bit of code generation in them, whether it's wrapping the database or other external services, or simply as a way to handle cross-cutting concerns. Code generation is something you will run into a lot. You'll also find that a lot of people do it poorly and end up hurting their organization. In this episode, we're going to discuss some anti-patterns of code generation that can jump up and bite you, and what you can do instead. But before we get started, Will, what have you been fighting this week?
Well, it's been a bit slow at work, just waiting on a third party to get back to me. So you send them an email and they don't respond for 3 days and you're dead in the water and you're hourly.
Mm-hmm.
That's a little bit uncomfortable. So I've been kind of dealing with that. I've been working on, book chapters for Simple Programmer for the remote workbook that I'm working on. And I'm ahead on that as a result. And I spent 3/4 of the day today watching movies and working on a Hexo theme. And I don't really have a good reason to do that. I just got tired of writing. So that's where things are right now.
Wow. So I've been on the go constantly. I have the opposite problem. Basically, the past 3 weeks have just been really hectic. I mean, right before we started recording, I was about to hit the record button. I got a phone call. Now, this one was from our worship director at church asking me about how to record on the soundboard because she's teaching a lesson. But it's just been constant the last few weeks. I know in the previous episode, I told you all about my grandmother going into hospice. Well, she passed away last week and I flew up for the funeral. We didn't record last Thursday because I was traveling. Well, actually, I was back, but it was so exhausting, just the whirlwind trip up there, that I was resting. It was a very nice service. I got to be one of the speakers. I spoke at my grandfather's funeral about 10 years ago up there. It was in the same room at the funeral home as my grandmother's service is in their larger room. So in happier news, I'm doing well in school. We had our second test this past Friday. So right after I got back, that's another reason we didn't record, is I was resting up and studying for that. I probably should have gotten an A on it, but with everything going on, I made just a few dumb mistakes and ended up with a B. Still, for a class that everyone told me I would struggle with and hate, I'm really enjoying it. The professor's been very understanding, and she's a really good teacher. So I'm learning this stuff really well, and she's really good about telling us, all right, this is what's going to be on the test. This is what I'm going to test you over because this is the information I want you to know.
Yeah, that would be great.
Yeah, she's a really good teacher, good professor.
Yeah, because when I had discrete, it was the worst math teacher I've ever had. So
yeah, if you have a bad teacher, I could see this being really confusing because...
Well, this was discrete too as well. So it was I got through one.
Yeah, that happened to me with Calc 2. I had a really great Calc 1 professor, and then I got to Calc 2, and I wanted my Thursday nights back because it was a night class. And so I went and took a day class, and the professor was not near as good as the night professor.
Yep.
So But speaking of good professors and communication, we're closing out our book in book club. So, Algorithms to Live By closes out with a couple of chapters about interaction with others. Chapter 10 talks about networking and how we connect. It starts by explaining the history of packet switching on phone lines and gets into topics like message acknowledgement and flow control in linguistics. Chapter 11 looks at game theory. In this chapter, the authors look at man versus man and man versus society. They delve into cooperation and competition. In the conclusion, they leave the reader with three pieces of wisdom. First, that some algorithmic approaches can be directly translated into our lives. Second, using an optimal algorithm should come as a relief, even if you don't like the results of that algorithm. And third, you can draw a line between problems with a straightforward solution and those without. Y'all, this has been a really good book. I suggest you check it out. We'll have a link to it in the show notes. Will, who's talking to us this week?
Well, we got a Stitcher review from Mad Dog X9. I'm assuming it's Mad Dog X9 and not Mad Dog times 9. Will and Beej do a great job at giving programming advice for a large audience. Their coverage of soft skills is fantastic, but even more impressive is their ability to cover very broad technical topics such as dependency injection without getting too domain or language specific. They also do an excellent job at diving into specific technologies like Jamstack from time to time, which brings awareness and provides a bit of an overview for listeners who might not be familiar with those technologies. No matter what programming paradigm, languages, or environment you work in, this podcast deserves a listen. Will and Beej, keep up the great work, guys.
Hey, Mad Dog, thank you so much for the kind words and the long review. That was really awesome. We appreciate that. We do our best to make our content as evergreen as possible and as language agnostic. So it's pretty obvious we're both .NET developers because we use that as our example a lot because that's what we're familiar with. Though we both dabble in several other languages.
Yeah, I'm like totally tempted to go to the Node dark side. I got to admit that. Every time I mess with it, I'm like, man, I like this.
So send us an email to waterbottle@completedeveloperpodcast.com because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or Stitcher or comment on the website or any of our social media. We post all our episodes to Facebook, LinkedIn, and Twitter. We're also on Instagram and Tumblr. You can join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
Code generation is an important part of most software projects today, whether the people involved know it or not. Lots of code is built on the fly for you with most tools, and for good reason. It's often easier to handle a lot of roughly similar code by writing code that writes the code. Tool vendors do this all the time with a lot of success.
However, we've all had the experience of working on a project where some dude came in and slung together a code generation framework in an afternoon. Far from creating a cleaner code base that's easier to work with and better for the team, most attempts at code generation in the wild usually end up wasting money and time. Not only is the code often hard to extend, but it's often accompanied by a raft of sloppy hacks as other developers try to work around its shortcomings. It's not because of code generation, it's because the people writing the code generators don't have a firm grip on how to avoid major problems, and because they fail to account for occasions where other people might need different behavior from the framework. It's very interesting that we're talking about this because we've had a consultant in at work and he was showing me a code generator that he had written. And I was like, yeah, this is some stuff that I've really been wanting to get into. And, he knows where I am in my growth. He's like, yeah, man. He's like, I've got about 20 years experience and it took me 7 years to write this.
Yeah.
I'm like, I'm not saying it would be easy or it wouldn't take me a long time, but I want to do something like this, or I have been, because it's really cool.
Yeah. And when somebody spends that much time and they've really worked at it, it's totally fine. Usually it's when it was thrown together to save time in the short run, that's when you get burned.
Yeah. So in this episode, we're going to discuss common anti-patterns of generated code in the hopes that you're better prepared for code generation than the average developer. We hope that when that day comes, you can return to this list so that you don't make the same mistakes Will's made in the past and I try to avoid.
Yeah, I've been that guy on several projects. So a lot of this stuff is directly related to screw ups that I have made. And there's no reason for the rest of y'all to hurt yourself in this same way. So I guess let's get started. The first thing that will really cause you a lot of pain is when you generate all the layers of the system in one step. So only use a single step of code generation to generate one layer. So, for instance, if you're doing a data access layer, don't generate your business objects at the same time and your UI at the same time. Because what will happen is these things get entangled. The idea is if you do a single step at a time, this keeps the scope of changes limited and keeps concerns from getting snarled together because you'll do code reuse and things like that. And it seems okay at the time, but it ends up hurting you.
So basically, the single responsibility principle still applies when building a code generator.
Yep. And it applies a lot more harshly, frankly.
Yeah.
Because stuff you could get away with before, it doesn't work well. Now, layers utilizing the current layer should be generated after the current layer from metadata. So the idea here is that you generate one layer and then there's some kind of metadata that comes out of that that you consume for the next layer.
Mm-hmm.
This helps force developers to keep the generated code from being entangled because the stuff is really hard to munge together and screw up. So, like, if you're not going to be maintaining this thing, this also helps the next guy fall into the pit of success.
Is that called the leaf to trunk approach?
I have no idea.
I've heard that term recently, and it seems similar to what it was described as, where it's you start with the dependencies and then you build back to what needs them.
Yeah, because they have to be there, right?
Yeah.
And you want to decouple with that metadata layer, which we'll talk about here in a bit. This also helps a lot if you need multiple variants of the caller. So, for instance, if you're doing a thick client that's local on the box and call in one way versus a web service client that's not. A lot of people will generate a client for both and then try to hack instead of, hey, let's just separate those two things.
Mm-hmm.
And so this just makes it easier to do that without as much pain.
The next anti-pattern is black boxing.
Yeah.
You need to be able to see what is going on in the generated code.
Yeah. And this includes the ability to step through it with a debugger because bear in mind, it is still code and you do still need to see what's going on. So when a null reference comes out of that, you don't need to go, well, there's a null reference. And that's as much as you can do.
Yeah.
Because I've been there, done that. That really sucks. And this also means that generated code assets should be raw source, not binary. So like don't generate it and then build a binary and go, okay, here's the DLL.
Mm-hmm.
That is not helpful. That does not improve the flow. A lot of people will do this because they don't want people going in and trying to mess with the generated code, but this is not the way to fix that.
Yeah. I've seen some code generators that were open source and you could pull it down, build the binary, and then use that.
Right.
So you could get in there and see what's going on in the open source code and then build your own binary based on what you need.
Yeah. And it's also helpful if you've got like the PDBs and all that kind of stuff. But for most people, if you're not building tools and, in like a work environment, you need to be able to step into the code just so that somebody isn't screaming at you about something being broken. They tell you what's broken and you can fix it.
Yeah. Yeah. Something I have run into, we were looking at taking some of just like our common functionality and putting it into a NuGet package.
Right.
This was a couple of years ago. And the developer that was working with me on it, she built a DLL and started using it.
Just raw.
Yeah. Just sticking it into some projects. And it's like, that's really cool. The only problem is after she left,
and you don't know what version it is either. Probably.
We didn't know where the DLL was.
Yep.
We had to get in touch with her and like reach out and be like, hey, I got to go maintain this code you wrote. Can you tell me where that DLL is you're using?
Yeah. Yeah. The other thing with black boxing too that gets you is, stuff like obfuscation, code minification. Like if you're generating JavaScript, that needs to be done later by some other tool. You're just generating code and it should be clean code that's actually readable by a human being.
Also, you need to make sure output, especially errors, are very straightforward. And this means that your framework should never emit a null reference exception. You need to generate something meaningful to tell the consumer what is null.
Yeah, because as you build your code generation framework up and the code gets more complicated, the number of people who actually need to look under the hood or who are qualified to look under the hood is going to decrease. And so you need to make it so that they can troubleshoot without doing that. Because you'll end up with a lot of Lambda functions and just, weird callbacks and all kinds of stuff. I mean, I've written plenty of code like this. And I have like an ASCII picture of a dragon that I put in there that's like, you're in danger if you're seeing this.
Yeah.
And that's the idea. So you do want to expose things in a way that people can figure out. The other thing you want to do potentially is consider having things like retry logic in the code where it's appropriate. So instead of just instantly failing, actually retry under the hood and handle things that are common errors, if you can, so that it never bubbles up and becomes a problem.
Yeah. You also want to emit events when certain conditions occur. Then your consumers can listen for those events and take further action.
Right. This is just a way to hook into the thing and people can actually see. It'll also help you when you debug. So for instance, like if you're creating a database connection, if you emit an event that says, hey, I created a database connection, do whatever you need to do when that happens. So you pass the connection in, they deal with it. Maybe they just write to a log. That makes it really easy to instrument these things without having to mess with the code generator itself.
And above all, make sure that someone without any documentation can quickly reverse engineer your generated code.
Yeah.
That's important.
Yeah, it is. I also say that this one is a really hard one to hit because you end up trying to handle things as cleanly as you can. And eventually you get into a spot that's like a very strange part of the language.
Yeah.
A lot of times. So you have to make sure that somebody that is qualified to get in there can do it, not junior dev that just stepped off the bus.
Yeah. Now, I will say the code generator that I was shown, the generated code was mostly like boilerplate stuff.
Yeah, it usually is.
It was stuff to make it so that a junior developer could come in and just start coding and not have to worry about setting stuff up.
Yeah.
Actually, it's really, really convenient and nice. I liked the way he had it set up. He showed it to me. I'm like, man, that would have made my life a lot easier when I was a junior developer.
Yeah.
Of course, now I'm at the level where I'm the one that's going to be setting that up for the junior developers, but that is what it is. The next one is sort of one of my passions, and that is logging, or the anti-pattern of no logging or poor logging practices.
Yeah. So consumers of your generated code need to be able to see what happened in a runtime environment without a recompile. This means that you got to have real robust logging, and you have to have the ability to redirect logs to different formats. So it's not just, we always write a text file. Because if you're in a server cluster somewhere and it's, we write out a local text file, what am I going to do? Like RDP into 15 different boxes and try to figure out which one got that part of the thing? Like, that's awful. I want to kick it to a database. So you got to use a real logging framework, and you cannot do the logger as glorified text stream anti-pattern.
Let me just say, that's, I'm not even going there.
Yeah. You and I will both rant there.
When it comes to the robust logging, no matter how robust you think your logging is, it could be more robust. I thought I had very good logging until recently, and I was shown, if you do this and add this, then you can see exactly where the breakdown occurs, and if something's not doing what it's supposed to do. And I'm like, oh my goodness, I didn't even think of that.
Yep.
And it's like, I thought I had really good logging.
Yeah, I mean, the key thing with any code, and especially generated code, is that your code should not have an opinion about what is important enough to log. It should have an opinion about what logging level that thing constitutes.
Yes.
You also probably are going to want to number the known errors coming out of your framework so that users can quickly find problems in the generator by error number. So if it's error, 2758, hopefully you don't really actually have that many, but in case you do, go in and find the line of code that has that, and you should be able to figure out what's wrong right there.
Yeah.
Versus, it's just a dum-dum, doesn't have the right database connection. Well, where did dum-dum set it up? I don't know.
Also, logging should include enough information to assist in debugging and modifying your code generator. Remember that the generator is also code, and it's subject to the same kind of problems as, the code it generates.
I periodically have to go and work on a code generator that I wrote over 5 years ago.
Yeah.
And, it's not very often anymore because it only does a limited amount of stuff, but every so often there's something. And you want to be able to get there quickly and get out, especially if, like me, you're not getting paid to fix those things.
Yeah.
That's kind of helpful. You also really just need meaningful error output when a problem occurs, even if it is doing nothing more than writing out to a console somewhere or writing out into the code itself.
Hmm.
So, like, it may be broken code and you might just write out something that won't compile and then put, hey, this is an error and I don't know how to fix this in the generator. It's right there. And they'll find it when they try to compile if you've got a compiled language.
Consider directly dumping errors as raw lines to your output files as well. If you're using a compiler, this will make the problems easy to find.
Yeah. Now, the next pattern that comes up a lot is there's no ability to override behavior. So, code generation is a good way to handle roughly 80 to 90% of roughly similar code. It goes sideways if you try to make it handle 100% of cases.
Hmm.
Let the consumer implement the weird edge cases and just stay out of it because now they have more time. They can do that because of your code generator. That's what it's for. Let it fulfill its goal here.
What's the 80/20 rule?
Yeah.
Pareto principle, is that right?
Yeah.
Yeah. The whole concept here is to get 80% of the repetitive, dull work done so that you can spend more than 80% of your time on the 20% of the work
Yeah.
that requires thought.
And makes a difference probably because those will be your most interesting problems anyway, most of the time.
Hmm.
Consider making an ignore list of components that you won't build. So, like if you're reading from a data source and let's say you've got database tables and you're generating models off of that, which you really shouldn't do, but let's say that you're doing that because it's not a good design. Anyway, consider making an ignore list to say, hey, I don't generate this for this table because there's something weird in there or whatever, and make it so that the client can make their own file by hand that still works with the rest of the system.
That's important.
Yeah.
You also want your code generator to act more like a library than a framework. You want it to work within your framework.
Yeah, and it shouldn't be holding hands and it shouldn't be making opinionated decisions. So, like the code generator does not get to decide whether I use this framework for logging or this other framework for logging.
Yeah. Well, I mean, if you're in like .NET Core, it should probably use the iLogger.
Right. And it should use the typical idioms for things like dependency injection, those kind of things. It shouldn't try to do something weird and different.
Yeah.
That's the other thing with a lot of people that write code generators is they're actually trying to do something else entirely.
Hmm.
And they're using a code generation. That's another reason it gets a bad rap on that.
Yep.
And this stuff is implemented differently in different languages. So, in a lot of languages, you need to only expose events that are consumed to modify the way the application works. So, hey, before this thing is committed, fire this event, let it process. And if they have something they want to hook in there, they can. They do the thing, and then it comes back to you. In other languages, you might use class inheritance or partial classes to handle this kind of stuff. So .NET, C# has partial class definitions. So you can have a class split across two files. This is done on purpose, specifically for code generators to work.
Hmm.
That's why they did it.
So, talking about building your models from your data tables, that's what Entity Framework does.
Yeah, by
It
default.
builds partial classes. Yeah.
Yeah, the partials, yeah.
Don't use EF, but I've seen it. Now, you might also extract certain functionality out into its own class and use dependency injection to put it in without having to touch framework code.
Right. So if there's pieces that you're like, hey, I'm not sure about this implementation, break it out into another class, dependency inject it, and if somebody wants to override it, they can.
Mm-hmm.
And then you don't have to mess with it. Like only generate stuff that you really need to generate. And speaking of things you need to generate metadata. And this is something that my favorite tool does not do.
So the next anti-pattern is not generating metadata.
Useful metadata about the generated code, its structure, and other constraints should be output in a form that can be used by other code generators further up the chain. While your choice of language may support a degree of metaprogramming, other languages may not support it as well, or they may not be able to reach into your code, right? So you may be generating code that is C# code, but something needs to interact with it that's JavaScript. If you're going to be generating code, you can't assume that even the same generator is going to be used. You have to write metadata that makes it agnostic.
Right.
This metadata that you're dumping out can also be used to generate unit tests to make sure that the code aligns with the output metadata. Because another layer of stuff that comes up is unit tests. If you generate your code, you probably should generate unit tests for it if that's what you're doing for testing. If you're doing cowboy coding and you're just slinging stuff at the wall to see what works, you do you.
Now, this metadata should probably be in a portable format of some sort. XML used to be popular. Now JSON is so much better. Come on, guys. These are both good choices. You want the format to be human readable so that anyone generating code from the metadata can do so easily. I would suggest JSON just because to me it's more readable, but I know some older developers who think XML is more readable.
Well, the thing about XML is there's common ways of doing schemas, right? So you could have it match a schema and you generate the code to act with that XML using a different code generator that's built into your IDE. Now, there are JSON schemas as well,
Yeah.
but people don't know about those about half the time. So that's why. Now, speaking about stuff people don't realize that hurts them, another anti-pattern is to directly hit an asset like a database. So during code generation, it can be really tempting to do things like directly querying the databases for data to use in code generation process. I do this in some of the frameworks I've built. I will tell you straight up that this is something that causes a lot of problems.
While this is simple, it also makes it a nightmare to write tests for your code generator. Oh my goodness, I couldn't imagine that.
Yeah,
Also, this approach tends to slow down the generation process a lot.
right.
It also slows down the development of your code generation templates.
Because every time that you want to test it, you're having to run against the database. And guess what? You're probably not the only one on that database. And so somebody can change things, and all of a sudden it looks like you broke stuff.
Yeah.
And you're also dealing with code generation that's code that's writing code, in addition to, hey, it's pulling it from somewhere else that I don't necessarily know that I can trust. That's a weird spot to be in. I've been there a few times. It's not real pleasant. And the other thing is, if you directly hit a database instead of a file full of database metadata, it also creates a few other issues. So, there's the whole shared database thing, which means that one team member editing the database can break code for everybody else. So, like if they're regenning every build and one dude goes, "Oh, we don't need this table," and he's fixed it in his code, but it hasn't pushed up, and he removes it from the shared database, he has broken the build for the rest of the team on their local machines.
Yeah.
This is part of the reason I really hate shared database, for devs. I think it's a bad idea for this kind of stuff, but it happens.
There's a couple of problems I see in that. Yeah. There's the generating code from the database and then the shared database and all that. But you talking makes me think of some arguments I've had with DBAs in the past about we're not using this. I need you to remove it. It's like, oh well, I'm gonna leave it in there just in case. I'm like, I'm the only developer working on this. No one else is in here.
Yeah, get rid of it while I'm the only one here.
Yeah.
Yeah, because then it's permanent otherwise.
Yeah.
It also means that development stops when the database server is down rather than the team being able to continue along.
Mhm.
And this can really be a problem as well. I've worked at companies that were doing performance tests on the database, and the database wasn't down. Let's just say that it was a little bit slow. You insert 90 million records and you do a contains query on it, and the database server is a piece of crap, and the whole team's relying on it. If you're having to regen off that database, you're going to be sitting there a very long time, and you're possibly going to get transient data errors as well. So if you just have it where it's coming off of metadata that is source controlled and not attached to the database, this isn't as bad. The other really handy thing about source controlling a file full of database metadata is that it can be really useful in reconstructing the database at a later date as it was at the time of a check-in, or for generating migration scripts, those kind of things.
Yeah, or if your database server crashes and you don't have a backup.
Or you decide to switch database servers.
Yeah. There's a lot of benefit to doing that. Now, the next anti pattern is a lack of ability to unit test.
Yeah.
Your generated code and your code generator itself need to be built in a way that allows you to unit test them.
Yeah. So instead of generating a single item by hand and then testing it, a code generator may generate dozens or even thousands of similar items. You'll want to run tests across them all to make sure that you catch weird edge cases early. So, for instance, if you've got a database that's got 300 tables in it and a whole bunch of weird relationships and triggers and all kinds of other stuff going on, and you generate a data model off this thing, there's going to be some weird edge case that happens that's going to break one of your tests. And you're going to go, okay, I need to fix the generator to make this not happen.
Mm-hmm.
If you're not unit testing, you will find that in production.
Yep.
On February 29th at 4:00 in the morning.
I recently read somewhere that the Greeks and the Romans considered leap day to be bad luck, especially for starting anything new.
Well, it cuts down on the cost of the anniversary parties of whatever. I mean, there is that. you know,
I don't know how accurate that is, but I read that somewhere.
yeah, it sounds like BS, but I like it. I'll
Right.
just run with it. I mean, like there's lots of motivational stuff that's right in that ballpark. So let's just go
Yeah.
with that.
Speaking of that, your code generators should also be built in a manner that allows testing as much as possible. When you have a large code generation process, you want to quickly unit test the thing just for a sanity check.
Yeah, especially if it's dependent on stuff that's downstream of it or upstream of it.
Yeah.
Like some other code generator emits metadata. Well, what if it emits something that your system isn't ready to handle? You can write a test, catch that, then you can fix your code, and then hopefully you don't have that problem again. It's like, I don't know, real software development.
Mhm. Also, your generated code should follow reasonable patterns of software architecture.
Dependency injection is the big one here that you're really going to want to use a lot of, as it's one of the best ways to introduce isolation testing across a huge number of generated components, because otherwise you're directly dealing with database connections. You're directly dealing with the file system or datetime.now, those kind of things.
Mhm.
Get that stuff out so that you can actually test it, because it's bad enough to not have unit tested code. But when you have a huge pile of it that nobody physically wrote, nobody remembers that code either when something happens.
Yeah. If you're generating code for systems that are object oriented, you should generally follow other best practices like single responsibility principle, open close principle, proper encapsulation. I mean, basic solid stuff.
Yeah, and you should probably also generate at least some of your unit tests and carefully watch to make sure you don't develop huge gaps in test coverage. You need to have something that says, hey, this percentage of the system is not tested.
Mhm.
Because when you have a code generator, it's real easy to make a whole lot of untested code in seconds.
Yeah. The next anti pattern is hand modifying generated code after it's generated.
Yeah, and I recently had to do this with the web service code in .NET Core because of the way that it's doing WCF stuff, and it was generating arrays of arrays when it should have been an array, and the bug has been there since 2016, and they're not going to fix it. So I had to go in and delete that. And I knew it's like if this ever gets regenerated, I'm going to get burned. You don't want to be in that situation because the next person that regens probably doesn't know about any changes you made.
Yeah.
So if you generate code, you should generally not modify it by hand after the fact. This creates a lot of problems. The first is it's really hard to fix all the places that you truly need to fix by hand without missing it. So for instance, if you fix, 15 places and there's 16 of them, you now have an intermittent error.
This code will also be overwritten when someone runs the generator again. I mean, that's the first thing I thought of when I read this was if you do that, it's going to get overwritten.
Yeah. And it's really not a if, it's a when.
Yeah.
And honestly, I think when you pull from source control, you probably should run the code generators and make that a regular habit so that people like that immediately get nailed instead of 6 months from now and then the person that ran the generator getting blamed.
Mhm. Yeah.
And needing to touch the final output tends to point towards deficiencies in your design that should be addressed. So if you need to modify the code, that means you probably really need to modify the template that you generated from.
This might also indicate that you need to have hooks and other ways to override the code.
Right.
That's why the partial classes are important in languages that allow for that,
Right.
because then you can generate the partial class and in another file that's not generated, add to it. Because if you add to the class that's generated when you generate it again, all that stuff you added just goes bye bye.
Yeah. The other thing that this will do a lot of times is it'll indicate that you don't have enough metadata when you're generating your code. So, like if you're having to go in and modify, well, why is that? Well, the template may be insufficient, but it could be that the template is insufficient because the template doesn't have enough information to know I need to do this other way.
Mm-hmm. Yeah. The next anti pattern is lack of performance counters.
Right. You should be able to tell how often a piece of generated code is hit, how long it takes on average to run, and that kind of stuff. This will help you watch for major performance issues.
A common thing that happens with generated code or any abstraction really is that less skilled developers will spend 5 seconds coming up with a mental model for it and then use that model forever, even if it was wrong from the start.
Yeah, especially if it was wrong about half the time.
Right?
So I worked with this dude, and dude bro, well, okay, I've worked with like 10 of these dudes. So this story is going to be a composite of 10 dude bros. Dude bro did not understand how entity framework contexts worked. And he was basically beating the daylights out of the database because every single time he needed to get data, he spun up a brand new context instead of, dependency injection and, just having one for the HTTP session. He was spinning up a brand new one. And so when you went in the SQL Server logs, you could see hundreds of thousands of calls to SP underscore reset connection,
Hmm.
which is what happens when a SQL Server connection transits the connection pool. And so he was just beating the crap out of the servers. The other thing he was doing is he didn't realize that certain things, like for instance, you pull back a list of things and they've got child records under them. If you don't pull back the child records, when you go to ask for those child records, it makes another round trip. And so he had select N plus one problems everywhere. And the reason is he treated it like, oh, it just opens a connection and gets me the things and all the things are there. And you'll find this with generated code. There's going to be a subset of the people that use it that will never look to see how it actually works. And they will create performance problems. So you need to have performance counters so that you can point at that guy and go, you broke this, not my code sucks.
Yeah.
Even if your code sucks.
I remember the first time I heard that story from you. I was asking you, I was working with someone that was doing something similar, and I was like, I know what they're doing is wrong, but I don't know how to prove it. And you told me that story, and you're like, here's how you show them. And I showed the person, and she's like, oh, I didn't realize that. We were both junior developers.
Yep.
So she was like, oh, I didn't realize that. And when it comes to anti patterns, it's one thing if it's a junior developer that legitimately just doesn't know versus it's a senior developer or someone that refuses to learn.
Yeah, or they think they know.
Yeah.
They've been able to get away with it on their local machine, but when you put it on a server with thousands of people hitting it, all of a sudden, everything grinds to a halt.
Mm-hmm.
It's really easy to do this. So don't have a bias towards how people pick stuff up or how you think you pick stuff up, because everybody has one or two areas where they've got a mental model of something that's completely backward.
Oh yeah. Oh yeah. I know. I've had a few of mine reshaped
Abruptly.
Yeah.
We had a friend that was really good at that. Usually in a way that was fairly humiliating too, but like he got you over your mental blocks real quick.
Oh yeah. But guys, basically, if your code works, people will use it without understanding it. And if you generated a bunch of code, they'll use it in a bunch of places.
Yeah.
You want to track resource allocation, database connections, memory allocations, handles, threads, that kind of stuff. Throughput and time required for operations.
By the way, this doesn't necessarily mean that you directly put timing and other instrumentation into your code. It might mean that.
Mm-hmm.
But you might also just need to have a strategy for this sort of thing, for troubleshooting performance. And this could be as simple as conditional compilation statements that dump this stuff out and they're not in there when you're building for release. And it could be as complex as adding in a library for instrumentation.
It could also mean having a third-party tool on hand that can do the work for you. That's usually a very convenient way of handling it.
Yeah, if you've got one of those. If you're in one of those cheap IT departments that won't spend $400 on a tool to save $10,000 because they've got some bean counter holding their thumb on everything, you may have to do this by hand.
Yeah.
So the next one that burns a lot of people, and I stopped doing this years ago because .NET actually got some decent libraries around this sort of stuff, is generating code using string concatenation instead of templates. It's really easy to dynamically write code using string concatenation. However, you're going to edit this stuff a lot. Code generation code is really hard to write because you have the two layers. You've got the stuff that you're writing and the stuff that it's writing, and both of them have to be correct.
Mm-hmm.
It gets really messy really fast. And if you use string concatenation, you end up dealing with a lot of nasty problems, stuff like escape sequences in large blocks of code, attempting to do multiple levels of string replacement, that kind of stuff. It really gets to be a problem very, very fast.
Yeah, I've seen some stuff like this online. and some open source things. And it's really hard to read and modify code that writes other code through string concats.
Yeah, and I have a friend that's using some that I wrote years ago to do some of his work. And, like I periodically talk to him. I'm like, why are you still using that? It's like, it still works. And I'm like, but you haven't looked at it. Like, it's not good. If you have to touch that, you're going to hate me.
Yeah.
Like you're going to hit me with your car when I'm in the Target parking lot or something. Like, this is not good.
Yeah. You'll also find that you spend an inordinate amount of time trying to format this code as well, both for use in the generator and for making it understandable once it's generated.
Yeah. So your code generator needs to be clean so that you can reason about it.
Yeah.
The code that it outputs has to be clean so that you can reason about it. If you're doing that with string concatenation, that's almost impossible to achieve. The idea of using a template language is so that you can look at the code and it looks kind of like what you're normally writing so that you can see problems. If you're doing string concats and escape sequences and all this kind of stuff, that gets really, really challenging really quick. And it won't be long at all before you can't maintain it. It just becomes a pile of code. If you use a template instead, you can kind of reason about the structure of the generated code. So you can see that, oh, wait, there's a missing curly brace. If you're string concatting that stuff, trying to figure out where to put that curly brace, that is like the least fun activity of all the activities. I've done this before. Like, just don't go there.
Oh man, you know what we should do a string concat code generator for one of our coding challenges in Developer Launchpad. That will train everyone there not to ever do that.
Or not to ever show up again, at least. Like, yeah, that will completely break you. I mean, and this is the way that we used to generate HTML, by the way.
Yeah.
Like if you did InterDev back in the day, it was kind of like that.
Mhm.
Or at least it wasn't far removed from that kind of stuff. It just,
Yeah.
don't do that.
Now remember that you're experienced in reading code in your language. You might as well keep the code generator to a similar structure as what you're used to reading.
Yeah. And the output of it as well.
Using templates can also help you convert a working code sample into a template very quickly. Rather than trying to rework the thing to use string concat, you can just copy it into a template and modify the things that actually change.
Yeah. And by the way, this is the best way to generate code is you make a working sample for one vertical slice of the app all the way up, including all the different pieces. And then you start moving those pieces into templates with the metadata coming out.
Mhm.
Then you can actually build the thing. If you try to write code generator code that writes clean code that actually works, that gets very difficult because it's like another weird layer of abstraction that you have to try to process, and you're just going to fight with it a lot more. So if you build it clean first.
It's a fun challenge, just like trying to create the entire template that I use for our show outlines in Emmet.
Yeah.
And then hitting tab in Visual Studio Code and having it just generate the HTML. Yeah, that's what that's doing, is trying to create the entire thing rather than, all right, I'm in this div, let me get the stuff in here. I'm in this one, let me get the stuff in here.
Right. And exercises in masochism, totally fine when it's your time. But when you're at work, not so much, right? Like you want to keep a good impression and you want to be effective. So, I would suggest not doing this unless everybody else is so far behind that they're not going to notice. And then just, go be crazy, whatever you want to do.
Now, the last anti-pattern we're going to talk about is the single file output.
Right.
A
So,
lot of code generators.
yeah, this is a pet peeve of mine. Visual Studio's T4 engine will dump out a single file unless you do some hacks and actually integrate with Visual Studio. So you can get the env DTE object to get passed in there, and then you can mess with it and actually write T4 code that talks to Visual Studio and does all the weird stuff. I tried for months and I never got it to work cleanly. I got it where every other generation worked, but the first generation would always end up with a file lock and it would crash. And I'm talking full on Visual Studio crash. And then you reload and then it works. So I strongly suggest trying to find something that doesn't do this. And the problem with a single file output, there's a lot of reasons, but the really big one is that as your code base gets bigger, this makes troubleshooting really nasty because the files get huge. So, for instance, in one of the generators that I've built in the past, I think the latest version has over 100,000 lines of code that it generates and it puts in one file. If you open that file, you hit the memory limit on Visual Studio or you get very close to it.
Mhm.
That's a really ugly place to be. This can also be a real problem when you or a coworker ends up regenerating code because if the generated code ends up in source control and you end up with a merge conflict when you have over 100,000 lines in a file, that is really, really not an impressive user experience for the person having to fix those merge conflicts.
You should be the one that has to fix those merge conflicts.
Right. If you just completely hit yourself in the face with this once or twice, like you learn real fast because it
Yeah.
hurts.
Instead of this, your output should be broken into basically the same structure as your non-generated code. And this can be tricky if your code generator has a bias towards single files.
If it does, you need to use a different one. I tried to get stuff working and if it's got that bias, like even if you try to hack around it, those hacks are going to have problems. You just need to use something that's built in.
You generate one piece at a time.
Yeah. But like orchestrating all those can be kind of interesting too. Like you almost need to have a package in there that can orchestrate a lot of generated code into separate pieces instead of, hey, I run all templates and it just dumps.
Yeah.
You also need to make sure that your files are named in a way where there isn't a naming collision. Because if you're generating a bunch of loose files and then you got partials, you need to think about how you're going to do that and have a scheme for this so that they don't overlap and you don't get a crash, get some kind of problem from that. Or accidentally overwrite one of your non-generated files because you named it the same thing as something you're generating.
Yeah. So, guys, most code generation in the wild is done in a sloppy manner that causes problems later. However, if you use reasonable patterns and design your code generator well, you can avoid a lot of these problems. Above all, you should treat generated code as a first class citizen with all that implies. This code may be building a substantial and critical part of your system. So it's important that it be treated with at least as much care as a similar code that isn't generated. Code generation by itself doesn't produce better code. It just makes more of it. That pretty much wraps us up before we close everything out. Will, what do you have for us this week for Tricks of the Trade?
Well, every time I've talked about code generation, there's always somebody that's like, oh, it generates bad code. It's always bad. And it's because they've had this experience, right? You'll run into this a lot in tech when you have an approach to things that is different than other people. You get hit with this and it's like, oh, that's just bad. It's like it's just a tool. Everything is just a tool. Okay. There is a time and a place for assembler code. And there's a time and a place for Java code. And there's a time and a place for generating Java code, for boilerplate type things. It's just that most of the time when somebody is desperate enough to do certain things that are work savers in the long term, they don't plan ahead to do it right. And it ends up not saving them. So just be really careful when you hear stuff like this, because a lot of times you're missing the undercurrent of what's really going on there. It's okay, well, we had this guy that was a junior dev who didn't really understand how databases worked and he wrote the code generator. Therefore, all code generation is bad. Well, what if he wrote in Ruby and the code was bad? Like, would you say Ruby's bad? What if he wrote on Windows? Would you say Windows is bad? I mean, you'd be right there, but be really careful when you're evaluating techniques based off of other people's anecdata, because this sort of stuff, you're doing this under the hood anyway. Like every time you have to talk to a web service that's like an ASMX, you're doing code generation probably in most platforms. You connect to it and you pull back some data, and then the code generation process happens because that data coming back is the metadata, that WSDL file. It tells your framework how to build the code to talk to this thing. And you probably don't really have a whole lot of problems with that code because somebody did it right. Just be really careful about how much you trust opinions and anecdata, including your own, about whether an approach will work, because it's really easy to get a single bad experience or a couple of bad experiences from people who did not prepare and didn't do things the right way, and to form an opinion of this. And by the way, you'll see this with upper management a lot of times too in companies where they're like, oh, like I heard one a few weeks ago about some code that I wrote a while back, and they didn't like that I had a function that called another function that called another function. that code should have all been together because some guy in the 80s wrote code that did that and it wasn't performant. And so never again. This is how you end up being that person in the corner office that makes dumb technical decisions. So stop falling for it here and you won't become that person later. That's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.